My name is Shoaib Khan. Today I am discussing about the deterioration of concrete in structures. Why concrete deteriorate in a structure means if the proper curing or faulty formwork or wrongly mixed design has been used, the concrete will deteriorate as early as possible. Concrete deteriorate take place over after many years, maybe from 50 years to 100 years in this between, or the concrete if having a poor strength it will start deteriorating from the 10 year also. What is deterioration? Deterioration means a defect that has been occurred over a period of time, as well as different defects can be involved in this deterioration of any given structures. There is a we can say that the most common defects we have to observe in the existing structures. uh, Therefore it is necessary to identify them properly. First, we can say that if there is a scaling in the structure, or disintegration, or taking a place of erosion, or corrosion of reinforcement, spalling, or alkali, or taking a alkali aggregated reactions, having cracking of concrete. uh, I will tell about scaling. What is scaling? Scaling is refer to the loss of surface portion of concrete, like or mortar. We can say that in this, it may be freeze or thaw. It is a physical action that is usually leave the aggregate clearly exposed. Disintegration, that it is a physically deterioration. In this, it break down the concrete in small fragments of particles. It starts from the star scaling also, and it may be also caused by de-icing chemicals like sulfates, chlorides, or by frost action. The concrete will deteriorate due to erosion also. Erosion in the deterioration of concrete surface may result of particles moving, like water scrubbing in the surface. When concrete surface is exposed to the waterborne sand or gravel, the surface will be deteriorated by particles. When the water is directly poured at the same with the force, particle will scrubbing against the surface. Flowing as particles can also cause the problem. Corrosion of reinforcement. Corrosion of reinforcement means if the corrosion of deterioration of steel reinforcement in concrete corrosion can be induced by chloride or carbonation. The corrosion can result in cracking in the concrete cover, delamination in concrete decks, etc. As we know that cement concrete is the most extensively used material in any different type of structures components such as building bridges, precast elements, etc. Because it's placed the compressive strength is placed on the concrete rather than environmental factors, which is directly affect to the concrete durability. Now I will discuss about the causes which have been taken causes of distress in concrete structures. These are the main reasons for serious deterioration of concrete structures, like concrete defects, or interior materials, poor concrete practice, or abuse of structures, environmental effects, chemical effects, or mechanical effects. In faulty design in concrete, these effects it can be said that faulty design. In faulty design, if the concrete is properly not mixed with the correct proportion, the concrete will start damage. The following are the main structural problems of concrete is discoloration, cracks, or scaling, crazing, and buckling. Now I can say that if in the adequate structural design, if adequate covers or improper joint detailing or incorrect placement of embedment in concrete is placed, or improper connection details has been used, there will be a faulty design. The most common design that concrete build have been experienced now. Interior materials is partially hydrated concrete and contaminated water. If the water is not properly used during the construction means if the water having a more pH value, the concrete started deteriorating, and that the concrete will not take the strength. If the concrete will be partially hydrated, it also affect the concrete. If we are practicing if we are using a poor concrete practice like faulty formwork in this if we have been using improper bracing can also cause a formwork failure, since we can say that the weight of fresh concrete is no longer supported by formwork system. And this incident can also can make a member to fail, and subsequent overloading or misalignment of other members result in the failure of the entire formwork structures. If the concrete have placing, when the concrete is placing, proper vibration or proper vibrator will not be used, it started deteriorating. Inadequate curing, if the concrete is properly not cured for days, the concrete will not gain the strength and it will started losing its strength and it will take to deterioration. Environmental effects in this we can say that the concrete also affect from thermal movements, also moisture movements, also surface erosion. Thermal movements, say if the temperature is too high, the perfect water will not is not available to the concrete. The concrete started releasing cracks which may be affect to the concrete. Moisture means due to the wind or due to the rainy season, the water which will be come from the like acid, it also deteriorate the small moisture particle which is present in the concrete, and this can also lead to a deterioration. Erosion in this we can say that erosion in the deterioration of concrete means the as a result particles moving in the water scrubbing the surface. When concrete surface is directly exposed to the waterborne sand or gravels, the surface will be deteriorated by particles scrubbing against the surface. These some of the related defects are internal stresses or mechanical causes also. Mean the following are the more common causes for the deterioration of concrete is chemical reaction, design error, shrinkage, temperature changes, accident loading, plastic shrinkage, drying shrinkage, etc. Now I will tell about plastic shrinkage. What is plastic shrinkage? During the period between placing and setting, most concrete will be exit bleeding to some degree. When the concrete is placed during the construction of a slab or uh, any other thing, the main time which is placing and setting is the most important time. Most concrete will exhibit bleeding due to some temperature or degree. These cracks occurs within few hours after placing concrete. When the concrete is placed in this, after some time the cracks will be take place. In this usually the bleed waters evaporate slowly from the concrete surface. If the environmental conditions such as the evaporation is occurring faster, then the water is being supplied to the surface by bleeding. So high tensile stresses can be developed. These stresses can lead to development of cracks of the concrete surface. Generally, this plastic shrinkage, these cracks are wide as well as shallow. These cracks occurs in the horizontal surface. In the space, crack space is 0.3 meter to 1.0 meter apart, and these cracks will be deep and having a width varying from 0.1 to 3 mm. These are the preventive measures to eliminate plastic shrinkage cracks. Moisten the subgrades and formwork. Erect temporary windbreaker to reduce wind velocity, as well as reduce the time between placing and finishing. If there is a delay, use polythene sheet. In this minimizing evaporation in evaporation, if we minimize the evaporation by covering concrete with burlap or any and curing compound, it will act as a preventive to eliminate shrinkage cracks which is present in this. Drying shrinkage. Drying shrinkage means it is a long-term change in volume of concrete caused by the loss of moisture. Generally, in this we can say that a concrete structure is subjected to some degree of restraint by foundation, by another part of a structures, or the difference in shrinkage between the concrete or at the surface that in the use in the interior of a member. This combination of a shrinkage as well as restraint causes tensile stresses that can lead to cracking. When there is a problem in combination of a shrinkage, the tensile stresses will be produced, which can also lead to a cracking. Preventive measures. These are the preventive measures which has been used in a drying shrinkage is we have to use minimum water content, and we have to also eliminate the external restraint as much as possible. In this providing adequate and early curing. In the these are the symptoms we can be easily identify if there is a drying shrinkage or plastic shrinkage. In the drying shrinkage, it's influenced by a numbers of factors such as cement content, water content, aggregates, curing, temperature. This crack generally confined to non-structure member. The total means drying shrinkage is made up of irreversible shrinkage and reversible shrinkage. These cracks may appear at 7 to 10 days after concreting, and 80% of drying shrinkage take place about a year. Generally, after the construction, the drying shrinkage will not take place. It may be take place after 7 to 10 days or after the completion of 80% of drying. At the time, drying shrinkage take place. Generally, drying shrinkage is caused by physical loss, means evaporation, or chemical loss. In chemical loss means hydration. If there is a hydration of water during the hardening process, drying shrinkage take place. These are the construction error which have been used. We have to take care of this. This error does not lead directly failure of concrete, but they enhance the defects of impact of other mechanism. First, adding water to the concrete. Adding water to a concrete, improper alignment of concrete or improper consolidation, improper curing, setting of the concrete, vibration of freshly placed concrete. While adding water to the concrete, if the water is excess, the construction error will take place, which may lead to damage to a concrete. If we're having an improper alignment of formwork, there will be means we can say that there will be no level, and it can be causes a damage to the concrete. Failure in this we can specify by procedures, good practice, or outright carelessness may lead to the number of conditions that may group together as a construction error. It also takes place due to the setting of the concrete. Why if we vibrate of freshly placed concrete, the error will be take place. Or we have improper finishing if we use of during the flat work, error will be take place. Design error, this is the main thing we have to notice in this. Design error can be taken in many parts, which can say that inadequate structural designs, poor design details, abrupt change in section, insufficient reinforcement at corners, incompatibility of materials. In this inadequate structural design, if we are not using a proper code book design, then the error will be take place and it will be causes faulty design error. Or and we can say that if we're not placing the concrete or in providing insufficient reinforcement at corners and opening, error will be take place. And rigid in design error, rigid joint at the rigid joint between precast unit, at that point error will also be take place. If inadequate joint spacing in slab, as well as a poor design details, this may lead to a design error in the concrete. In this, the main change is settlement and movement. In this is a two type of mechanism in settlement and movement is the concrete structure member, differential and subsidence. Single element of structure such as monolith is moving with respect to the remainder of the structure or causes by the subsidence. In this case, subsidence of the concerns are not overcracking or spalling by rather stability against overturning or sliding. In this, various elements of structures are moving with respect to one another. In this lead causes by differential movements. It is increases the member subjected to overstress conditions and cracks will be appear during the settlement or we are moving the temperature changes. If there is a change in temperature, it may also changes in the volume of the concrete. Basically there are three type of temperature changes that may causes to damage to the concrete. One is generating internally by the heat of hydration of a cement, and the second one we can say that by variation in climate condition, and the last one is from external source fire damage. These are the symptoms and preventive measures used. First, from crack from internal restraint will be shallow and isolated. Cracks from external restraint will extend to full of section. Using of low heat cement and placing of concrete at minimum practical temperature. By using this, we can we can see that we can control the cracks which have been present in the crack, and we can also we can also be safe that the concrete will be not destroyed as early due to some these reasons. In this we can say that it is this reduce is prevented by external condition. The concrete is when the extremely restrained and cracking error will take place. In this, temperature induce cracks and are perpendicular to large dimension of crack. Due to the temperature, the crack will be take place. By selecting aggregate, we should have low modulus of elasticity and low coefficient of thermal expansion. These are the preventive measures to selecting the concrete. This is abrasion error. Abrasion refers to the wearing away of the surface by the friction. Erosion refers to wearing away of the surface of the fluid. The shape and surface structure of aggregate play an important part in the abrasion resistance of the concrete, or using of steel fibers and polymers based system in concrete matrix improve abrasion resistance of concrete. In this, the more compressive strength, the higher the resistance to abrasion, erosion and cavitation. If there is a more compressive strength, it will resist to abrasion as well as erosion and cavitations. In this, cavitation occurs or refers due to non-linear flow of water. In this, the shape and surface structure of aggregates plays an important role in the abrasion for the resistance of the concrete. The concrete which are be using in the road or floors, pavement, the concrete which is and the concrete used in the hydraulic structures should be exhibit resistance and should be against abrasion, erosion and cavitation. Thank you. Now I will end my topic.